Good morning, students. Let's continue with topic mole concept from chapter number 3. Students, so far we have established a relation between mole and number of particles of a substance. Today we will be going to establish a relation between mole of a substance and mass of a substance. And what is the relation? Students, 1 mole of a substance is always equal to molar mass of a substance, which means if we have a carbon, then 1 mole of carbon will be equal to molar mass of a carbon. Similarly, for 1 mole of carbon dioxide, it will be equal to molar mass of carbon dioxide. So the question is, what is molar mass and how it can be calculated or known? In order to understand molar mass, first of all we have to learn about some old terms related to mass and some new terms. So let's begin. First of all, atomic mass. Students, you have already studied that atomic mass is the relative mass of atoms as compared with the mass of an atom of carbon-12 isotope taken as 12 units. And you also know that atomic masses of various elements like carbon is 12U, oxygen is 16U, sodium is 23U, and so onwards. Next is gram atomic mass. It is the quantity of an element whose mass in grams is numerically equal to the atomic mass of that element, which means gram atomic mass is numerically equal to atomic mass but taken in grams. Let's understand this with the help of an example. Students, we know that atomic mass of carbon is 12U. Therefore, gram atomic mass of carbon will be equal to 12 gram. Okay? So in simple words, gram atomic mass is the same number that we used for atomic mass, but it will be taken in terms of grams instead of U. Similarly, we know that atomic mass of oxygen is 16U. Therefore, gram atomic mass of oxygen will be equal to 16 grams. So students, if we know about the atomic masses of an element, we can know about or we can calculate the gram atomic mass of that element. It will be the same number but taken in grams. Next is molecular mass. It is the sum of atomic masses of all the atoms in a molecule of a substance, and it is expressed in atomic mass unit U. This we already know. The new term over here is gram molecular mass. So what is gram molecular mass? It is the quantity of a substance whose mass in grams is numerically equal to the molecular mass of the given substance. For example, we know how to calculate the molecular mass of carbon dioxide. We already have discussed this in previous videos. Now, molecular mass of carbon dioxide will be equal to 44U. Therefore, gram molecular mass of carbon dioxide will be equal to 44 grams. So in simple words, we can say gram molecular mass is numerically equal to molecular mass but taken in terms of grams. So students, if we replace U with G, then the molecular mass becomes gram molecular mass. Similarly, if we replace U in atomic mass, then it will be known as gram atomic mass. Similarly, if in formula unit mass, if we replace U with G, it will be known as gram formula unit mass. For example, formula unit mass of sodium hydroxide is equal to 40 U. Therefore, gram formula unit mass of sodium hydroxide will be equal to 40 G. Students, it has been found out experimentally that mass of 1 mole of atoms is equal to gram atomic mass of the element. Similarly, mass of 1 mole of molecules is equal to gram molecular mass of the substance, and mass of 1 mole of formula unit in case of ionic compound is equal to gram formula mass of the ionic compounds. And students, we know that mass of 1 mole of substance is called molar mass. That means all these three terms, that is gram atomic mass, gram molecular mass or gram formula mass, they represent molar masses. Which means in case of atoms, molar mass will be equal to gram atomic mass of the element. In case of molecules, molar mass will be equal to gram molecular mass. And in case of ionic compound, molar mass will be equal to gram formula mass of the ionic compound. So in short, we can say molar mass will be equal to either gram atomic mass or gram molecular mass or gram formula mass. And we already know that 1 mole of a substance is equal to molar mass of a substance. Now come to back exercise question number 6 present on page number 44 and try to solve question number 6, that is calculate the molar mass of the following substance. First part, ethyne, formula C2H2. Now students, since C2H2 is a molecule, that means in this case the molar mass will be equal to gram molecular mass. That means we have to calculate the mass in the same manner as we were calculating the molecular mass, but in the end, instead of writing U, we will be writing G. So, molar mass of C2H2 will be equal to 2 into atomic mass of carbon plus 2 into atomic mass of hydrogen. The same manner as we were calculating molecular mass. And on substituting the values of atomic masses of carbon and hydrogen, that is 12 for carbon and 1 for hydrogen, the answer comes out to equal to 24 plus 2, that is equal to 26 G. Note down students that since we are calculating molar mass, we will be writing G in place of U. If you were asked molecular mass, then you will be writing U, but if you are asked molar mass, you will be writing G. Similarly, for any atomic substance, that means substance which is made up of atoms, for example, let us say sodium, atomic mass is 23 U, so its molar mass will be equal to 23 G, that is the gram atomic mass. So students, solve the remaining parts of question number 6 in your notebook. Students, many times in mathematics we have studied that if A is equal to B and if A is also equal to C, then that means B and C will also be equal to each other. That is, B is equal to C. Using this relation, now we will establish the final relation between molar mass and the particles of the substance. Students, we have already studied that 1 mole of a substance is equal to 6.022 into 10 raised to 23 particles of that substance. Also, we have studied that 1 mole of a substance is equal to molar mass of a substance. So if this is A, and if this is B, and if this is C, so in this case A is equal to C and A is also equal to B. So we can say that finally C and B will also be equal to each other. That means we can say that molar mass of a substance will be equal to 6.022 into 10 raised to 23 particles of that substance. So from here we establish a final relation, that is between the molar mass of a substance and the number of particles of that substance. And the relation is molar mass of a substance is equal to 6.022 into 10 raised to 23 particles of that substance. Also, we know that the formula that we require to solve mole and the particles of a substance that establish the relation between them is small n is equal to capital N by N naught. And the formula that establishes a relation between mole and mass is small n is equal to small m by capital M. So using these two formulas, that is small n is equal to given mass by molar mass, number of moles equal to number of particles by Avogadro's number. From 1 and 2 we can say these two are equal to each other, that is capital N upon N naught is equal to small m by m, or in short we can say capital N is equal to small m upon capital M into N naught. This is the formula that establishes the relation between mass and particles of that substance, where small n is equal to number of moles, capital N is equal to number of particles, capital M is equal to molar mass, small m is equal to given mass, and N naught is equal to Avogadro's number. Now, using this relation or this formula, now we will solve some numericals in which we have to find either the number of particles from the mass or vice versa. So question number 1. Calculate the number of particles in 46 gram of sodium atoms. Now in this case we have to find particles and we are given mass. And we know that molar mass is equal to Avogadro's number of the particles. So since sodium is an atom, so molar mass of sodium will be equal to atomic mass, that is 23 g, because its atomic mass is equal to 23. And using the relation molar mass of substance, that is 23 gram of sodium, is equal to Avogadro's number of atoms of sodium. Therefore, for 1 gram of sodium it will be equal to 6.022 into 10 raised to 23 divided by 23, and for 46 gram it will be equal to 46 into 6.022 into 10 raised to 23, that is equal to 12.044 into 10 raised to 23 sodium atoms. Or we can also solve this question using the formula capital N is equal to small m upon capital M into N naught. In this case given mass is 46 gram, that we are already provided. Molar mass, we know that of sodium it is equal to 23 grams, and we have to calculate the capital N, that is equal to number of particles. On substituting the values, we calculate the number of particles, that is number of sodium atoms. Next question. Calculate the mass of 3.011 into 10 raised to 23 number of nitrogen atoms. Now in this case students, you are provided with the mass of the substance and you have to find the number of atoms, which means again the relation is between mass and particles. That means we will using the relation molar mass of a substance is equal to Avogadro's number of particles. Now since in this case we are provided particles and we have to find the mass, therefore we will write down particles on left hand side and mass on right hand side. So according to the relation 6.022 into 10 raised to 23 number of atoms, this should be equal to molar mass, and we know that for nitrogen atomic mass is 14, therefore molar mass will be equal to 14 grams for nitrogen atoms. So for one nitrogen atom it will be equal to 14 upon 6.022 into 10 raised to 23. Hence for 3.011 into 10 raised to 23, this comes out to be equal to 14 into 3.011 into 10 raised to 23 divided by 6.022 into 10 raised to 23. And on solving, answer comes to be 7 grams. This question can also be done using the formula capital N is equal to small m upon capital M into N naught. In this case, number of particles they were given 3.011 to 10 raised to 23. Molar mass we know it is 14 grams, and Avogadro's number we already know it is 6.022 into 10 raised to 23, and we have to calculate small m, that is mass. So on substituting the values and on solving, the answer comes to be 7 grams. So in short we can say that if we learn this diagram, this triangular relation between mole, particles and mass, we can solve any question related to mole concept. Okay, you can either use the unitary method or you can use these formulas which will establish the relation between the two different terms.
In the previous part of the video, we saw that 1 mole of something is nothing but 6.022 times 10 raised to 23 particles. It could be atoms or molecules or anything. If I give you 1 mole of pure gold, then what will the number of atoms in it be equal to? Yes, these many atoms. And 1 mole of pure water will have these many molecules. But what is the scientific definition of a mole? Scientifically, 1 mole is defined as the amount of substance that contains the same number of atoms, molecules or particles as there are atoms in 12 grams of carbon-12. Yes, even I didn't understand it when we read it for the first time. Let me break it down for you. Let me remove this definition from the screen. What we have on the screen now is 12 grams of carbon-12. Carbon-12 is one of the isotopes of carbon. Now 12 grams of carbon-12 is what was taken as a standard. What's so special about this? Can you guess the number of atoms here? Yes, it's 6.022 times 10 raised to 23 atoms. Now that you've understood this, let me repeat the definition for you. 1 mole is defined as the amount of substance that contains the same number of atoms, molecules or particles as there are atoms in 12 grams of carbon-12. Did you understand the definition now? It consists of two simple parts actually. It tells us that this part is equal to this part. The number of particles in 1 mole of a substance is equal to the number of atoms in 12 grams of carbon-12. That's it.